First of all, I want to express my warm thanks to Professor Song and his group for organizing this symposium in the difficult condition of a COVID pandemic. My presentation concerns the impact of soluble HLA G and PD-L1 that regulate immune attack process during a cancer cell mitosis. By a cinematographic study in collaboration with Professor Pushle CNRS, we observed via an in vitro study by cinematography that lymphocyte cell, once in contact with cancer cells, they can attack and destroy them. We have observed that the cells in the dividing phases resist and are not destroyed. Here, this experiment, you can see the keys of death. We incubated the leukemic cancer cells with cytotoxic lymphocyte. Here, the cytotoxic lymphocyte from human that added to cancer cells, key leukemic cancer cells purified in the plasma condition. You can see the cells that adhere to cancer cells, lymphocyte to cancer cells, and destroyed the cells. And the cells ejected the cytoplasm. This is in several stages. First, the lymphocyte recognize the cancer cells. After, this is the lymphocyte, cytotoxic lymphocyte, and cancer cells. After this interaction, the cancer cell destroyed, and after lysis, the cytoplasm of these cells. Here you can see the cancer cells with immune cells and the lysis of the cancer cells by these cells. You can see the very activated lymphocyte here that adhere to cancer cells. In this experiment, all the cells not destroyed. Some of them can resist to immune attack cells. Here you can see the cancer cells and lymphocyte that adhere to cancer cells. Some of the cells can resist. Here you can see that lymphocyte adhere to cancer cells, but the cancer cells not destroyed. Several lymphocytes attacked the cancer cells, but cancer cell is always in line. What happened? In this condition, we can see we are in mitosis event, and the cell divided, and cancer cell divided in two cells. When cancer cell divided in two cells, the new cells can be attacked by a lymphocyte and eliminated. One or several cells can attack one cancer cells. One or several immune cells can attack only one cells for destroy these cells. Here you have the lymphocyte and cancer cells and destruction of the cancer cells after by lymphocytes cytotoxic after 10 hours. The same experiment we repeat with the ovarian cancer cells of cell line. Here in blue, you can see the of cells. And we added the lymphocyte, cytotoxic lymphocyte, allogenic first. They agglomerated around the cancer cells. And attacked the cancer cells. And we can observe the lysis of cancer cells after these attacks. Here you can see the lysis of cancer cells. In several the lysis of cancer cells, the majority of the cells will be attacked by immune cells, and off-car cell can be lysed by after attack, and you can see the cytoplasm that come from the destroyed cells, lysis cells. After this observation, we have invented a test, a real-time immune cell attack assay, to analyze the impact of the microenvironment on the interaction of immune cells with cancer cells in vitro. We found that the cancer cell during their cell division resisted to attack by immune cells. So our aim is to find the molecular mechanism that can be involved. Cell division cycle, we have G0, G1, S phase, G2 phase, and mitotic phase. Mitotic phase divided in prophase, metaphase, anaphase, and telophase. After screening of ovarian cancer of CAR3 cell line with several specific antibody against the protein implicated in the immune checkpoint, we choose HLA, G, and PD-L1 as actor protein. Here, the green present HLA-G, the red present PD-L1, and the cells stained by DAPI. The nuclear is blue. Here we can observe all the cell in prophase, metaphase, early anaphase, and telophase, and before division, the cell can express in high quantity of HLA-G, but in other cells, in G0, G1, we cannot find a significant quantity of HLA-G. PD-L1 is present in all the cell, but in majority, very good amount in the cell on mitosis. What is HLA-G? HLA-G is a non-classical major histocompatibility class 1 protein that expressed by trophoblastic tissue at the maternal fetal interface. And they present set isoform that 4 bound to membrane and 3 are soluble in plasma. They inhibit natural killer and T cytotoxic cells and inhibit the immune attack cells. HLA-G, several isoform of HLA-G can interact with the cells. Alpha 3 can interact by T cell, NK, B cell, monocyte, macrophage, and dendritic cells. Alpha 3 directly via CD 85D can interact with monocyte, macrophage, and dendritic cells. Alpha and isoform can, via a KIR receptor, can interact with T cytotoxic and NK. In cancer immunotherapy, HLA-G is an important neglected immunosuppressive molecule. What is the PD-L1? One of the immune checkpoint most studied in the context of clinical cancer immunotherapy. They express it by tumor cells and interact by PD-1 from T cells, bind to PD-1, express majority of tumor-infiltrating lymphocyte, rendering the less susceptible to T cells. Our hypothesis is confirmed by several methods. Here we present the initial screening through flow cytometry analysis. Facts. In this protocol, we fixed the cells with methanol and analyzed by antibody, anti-PD-L1 and anti-HLA-G here. And we calculated the profile of cell cycle here. And the result presented here in G1 S and G2 phase. All the experiment in parallel for two cells, leukemic and ovarian cancer, was performed. Here, when we analyze the immunoreactivity of HLA-G or PD-L1, and we divided this in 10 compartments in equal percentage of the cells were calculated for their fluorescence intensity. And we conclude that we have identified low, intermediate, and high expression of HLA-G in leukemic cell as well as off-care cells. In this experiment, we concluded majority of the cells express intermediate or high level of HLA-G are in G2M phase. The same experiment repeated with PD-L1 antibody, and in contrast to HLA-G, the percentage of off-CAR3 G2M cell that express high PD-L1 is lower compared to low and intermediate expression. Majority of that express high PD-L1 are in S phase. When we analyze the G0, G1, G2, M, and S in a geometric model, we can conclude the positive correlation was found with G2M phase. That means cells are more resistant in G2M phase compared to G0, G1, or S phase. We confirmed all these results by real-time immune cell attack assay. In that, we used HLA-G and PD-L1 purified protein. The addition of this protein to in this test can inhibit cancer cell attack by immune cells. In another way, we synchronize the cells and we analyzed the interaction of this immune cells in G1 using lovastatin, in G2M using inhibition of CDK1 and use it in mitotic phase using nucodazole drug. We found that cells have lowest expression of HLA-G in G1, G0 phase, while the highest expression in G2M. There is no significant relation between S phase and expression of immune checkpoint inhibitor. The amount of HLA-G presented here in different phase, G1, S, G2M, and early mitosis for OVCAR3 and K and leukemic cell line. We can observe the maximum of expression are presented in early mitotic phase. And this cell in the movie, the cell that resist to immune attack of they found in this region of this diagram, and they are express very high quantity of HLA-G. We found the same for but the same result by PD-L1 antibody, and via this result we put this hypothesis that the cells in G1 phase secrete low quantity of HLA-G and PD-L1. In this condition, the immune cell can attack the cells and destroy the cancer cells. But when in mitotic phase, G2 mitotic, we can the cell secrete high quantity of HLA-G and PD-L1. HLA-G and PD-L1 secreted in around of the cells and can fix on the activated lymphocyte, and they block the cell attack, and finally the cancer in mitotic phase can resist to attack of immune cells. In conclusion, cancer cell express lowest level of immune checkpoint inhibitor in G0, GN phase, and this is very important for immunotherapy. All the results, for more information, you can see this article newly published in Cancer. Thank you very much. Best New Year's for next year, 2021.